Hello, everybody. All right, so what we're going to look at today is exponential functions. So this is just kind of an introduction to functions. We only have four things we're going to talk about. So we're going to look at evaluating, we're going to look at graphing, and then evaluating functions with base of e, and then using the compound interest formula. So the definition of a exponential function is going to be into this format here, where you have f of x is equal to b of x, or y is equal to b of x, either or. Some key characteristics that you need to know and understand is that your b must be positive, and it has to be, which means it has to be greater than 0, but it cannot equal 1. All right, so if it's ever equal to 1, then that's not really an exponential function. It's just going to be a straight horizontal line because 1 to the any power is always going to be 1. So in order for it to be an exponential function, it has to be positive. So your base has to be positive, and you have to not equal 1. So if you take a look at it, these are what your problems are going to kind of look like. And so if I'm looking at this one here, this is my base. I know all my bases. It cannot have a variable in the base. It cannot be the number 1, and it cannot be a negative number. Now, what's going to happen later on is you might see a negative in front of it. So what you're actually doing is you're saying negative 1 times 2 to the 3x plus 1 power. Okay, so just because there's a negative sitting here, that's just saying that you have something that's going to look along the lines of this, instead of it just being written as this, because this x is only going to that base of 2. It's not touching that. If you had something like this, that's a no. You can't do that. But what you can do is you can do this piece here, because this implies that you are actually doing that. Okay. And then your exponent here, that's going to be your exponent. That's where your variable is going to live. So that's when it's going to make this an actual exponential function, is the fact that your exponent is actually in, your variable is actually in the exponent. Okay. So evaluating. So they're going to give you a problem that looks like this, and basically they're going to want something from you. So in this case, they want to know what the average amount spent to the nearest dollar after 3 hours. So it's literally a plug and chug here. So what's going to happen is you're going to go and you're going to put this in your handy dandy calculator, and then you're going to get an answer. So when you put it into your calculator, you're going to wind up with this as an answer. Now, with that being said, some of your problems might have multiple parts to it. And if that's the case, what you're going to do is you're going to come over here, and instead of putting it in like this and getting an answer, you're going to go ahead and put it into your calculator like this. And then we're going to raise that to the x power. So what that's going to do is we're going to come over here to table set and make sure that your independent is set to ask. And then you're going to come over here and you're going to generate your table. So if the first question says, when x equals 0, then you type in 0. If part B says when x equals 1, then you'll type in 1. If part C says in 3 hours, you type in 3. And if part D says 15 hours, you type in 15. And there, all your answers are right there. And all you have to do is just transfer those over. So if you have a multiple part, and you'll have a multiple part before you actually get into it, just simply go ahead and stick this into the y equals, and then just run it off of a table. So that way you can get your answers from here. Okay. But for this question here, it wants it to the nearest dollar. So after 3 hours, people have spent $160. All right. So let's talk about graphing. For graphing, what's going to happen is you have this parent function here, and you're literally going to plug it into the calculator. They're going to give you a table that you'll need to fill out. So we're going to look at what that looks like. And then you're just going to plot those points Well, actually, you're not going to plot the points. You're actually just going to look at the multiple choice. This is the multiple choice part, and just determine which one of the graphs actually match the table that you set up. A couple of things that you need to know is that domain is always, always, always for an exponential function will always be all real numbers. And as long as you're in this format right here, your range will be from 0 to infinity. You will not have any x-intercepts. Because of number 3, you have a horizontal asymptote at y equals 0. That's why you don't have any x-intercepts. And then as long as, again, you're in this format here, it will always contain the point 0, 1. If your b is greater than 1, okay, it could be any number. It could be 9/5, it could be 17. It doesn't matter. As long as it's bigger than 1, you're going to have a graph that looks like this. So notice that it's going to run along the x-axis, and then it's going to curve up. If it's between 0 and 1, you're going to curve down. So basically this is saying as my x's are getting bigger, my y's are getting smaller. On this one, as my x's are getting bigger, my y's are getting bigger. So you have a growth pattern here and a decay pattern or a decreasing pattern here. Okay, so just keep in mind when you're looking at those graphs, this is a quick way to decide, all right, if I have 3/4 to the x power, I know 3/4 is going to be a decay, so I need something that looks like this. So you're going to have to actually graph your functions. So what it's going to do is it's going to give you a table that you'll actually need to fill out. So you're going to create this table. And so it's going to give you these numbers here. And then what you do is you take these numbers and you're going to evaluate those numbers. So that's the first part of what you're going to do. Once you've evaluated those problems, part B says, all right, you've made this table, you have these values, which one of these graphs looks like your table? And then you just have to pick the graph that looks like your table. And that's all it is for graphing. It's just picking the graph that looks like your table. Okay? So the same thing here. So if you have this, you're going to create your table. And so they'll have this piece already filled out for you over here. And then you're going to take this table and they're going to have 4 graphs here, and you're just going to pick which graph looks like your table. This piece here is just if you need to know about some transformations or stuff. So if you need to pause this video to write this stuff down, you can. This talks about your translations. So that's what this piece up here is talking about, is all your translations. And this is what it's going to wind up doing. Your reflection. So if we're reflecting over the x-axis, the negative is going to go on the front. If you're reflecting across the y-axis, your negative is going to go up here with the exponent. If we have any vertical shrinking or horizontal shrinking, notice that where that C value is going to go. If we're looking at vertical, it'll go up here with the base. If we're looking at a horizontal, it'll go up here with the X value. So just keep this in mind as you're looking at these things. If you're trying to figure out what graph or what your graphs are doing or whatever, you just take a look at this chart and it will show you or tell you what's actually happening with the actual graph. So you're going to look at the base parent function and say, okay, if this is my base parent function and I'm doing all this random stuff to it, what is it that I'm actually doing? And this chart here will actually be able to show you and tell you exactly what you need to know. The good news is you have a calculator, so you can just put it into your calculator and take a look at it, and then you won't have to worry about anything else. So the graphing part's actually really easy on this one. All right, so let's talk about natural base E. Natural base E is basically a number. E is a number. It is not a variable. Please do not use it as a variable. The reason that E is represented, or this number here, this 2.718, so on and so forth, is actually represented by the letter E is because this is actually the equation that is used to generate the E value. And so what it's saying is as my n gets bigger, so I can actually plug this in the calculator and look at it, you're eventually going to approach this value here. But because we actually are approaching it, it's a horizontal asymptote. So we actually will never reach the value of E. And that's why it's irrational, because we'll never reach it. And it just keeps on going forever and ever and ever and ever. So usually we do 3 decimal places. Sometimes we do 2. So if we do 2, just use the 2.72. There's actually an E button on your calculator that you can use. So if you're looking at your calculator here, this E button, that's right here above the division. You go second and then the divide sign. It will actually give you the E. And if you need to look at it in terms of this format right here with the X value, that would be second natural log, and that will give you the E to be able to put into the exponent. So what you'll do here again is just they're going to give you a problem, and they're just going to have you evaluate. Again, if you have multiple parts to it, stick this whole entire problem into Y1 and run your table so you can go ahead and have all your answers in one place. However, if it's just a one and done, so you just take this. The only piece of information that we need from here is that we need to know how long it is from 1978 to 2012. So 2012 minus 1978 gives you 34. So I know my X value is going to be 34. So I plug that into the X up here and I get my answer. So that means there's roughly going to be about 44 or 4,445 wolves in the year 2012. Okay. So compound interest, that's the other formula that you're going to see. Now, with that being said, in compound interest, there's usually 2 questions on your test. One is this with using this formula here, where you're actually compounding for specific times or specific times throughout the year. So that is what this A equals P times 1 plus R over N to the NT. That is what this formula is here. That is your traditional compound interest formula when you're actually compounding like 4 times a year, 52 times a year, once a month, whatever it is. If you're compounding continuously, basically that means there's no breaks in it at all whatsoever, then you're going to use this formula here, the continuous compounding, which is A is equal to P E to the RT. So notice the difference between the two. We still have an R and a T, but we no longer have that N piece because that E took care of the N piece. So what do all these letters stand for? Your A is always going to be your ending balance. Whatever your ending balance is, that is your A. Your P is your principal, is your starting balance. So how much you're investing, how much your house is worth, whatever else it is. R is your percent, but please, please, please make a note somewhere. R, when you put it into the formula, is not how it's written. You do not put in, if it's 8.2%, you do not put in 8.2. You must put it in decimal form. So when you put R into your formula, it is 0.082. Make sure you put it into decimal form, otherwise you're going to get a wrong answer. Time is always in years. So if I'm talking about time in years, 5 years, that's okay. I can use T is equal to 5. But if I'm talking about 18 months, I cannot put the number 18 in. I have to put it in terms of years. So if I'm talking about months, that means I have to go 18 divided by 12 because there's 12 months in a year. If I'm talking about 472 days, I take 472 and divide it by 365. If I'm talking about 93 weeks, I take the 93 and divide it by the 52. You always have to maintain that 1 year status. Okay. So just be aware of that because some of your questions will say, we're only investing this money for 4 months. Well, that 4 months is 4 divided by 12. So pay attention to that. Your N is how you're actually going to be compounding. So there's some key words that you're going to need to know and understand. These are your key words when you talk about compounding that you're going to need to know. Primarily the ones that you are going to be using will be quarterly, monthly, and weekly. They will use some of the other ones, but your main three that you're going to be using for the context of these problems that you're coming up on are going to wind up being these. Annually, once a year. Semi-annually is twice a year. Bi-monthly means you get 2 paychecks a month. You're paid on like the 1st and the 15th. Bi-weekly is you get paid every other Friday. So that's why you wind up with 26 paychecks, and that's why twice a year you get 3 paychecks in a month. Then we have weekly, then we have monthly, and then we have daily, and we have quarterly. So this is what all of these look like going in to the actual problems. So when you're trying to figure out what your N is, make sure if you don't know, take a look at this chart and it will help you. So these are what your problems will look like. A sum of $10,000 is invested at an annual rate of 8%. Find the balance in the account after 5 years, subject to quarterly compounding. So the first thing that we're going to need to do is come here and answer all these letters here, because we have a formula that we have to use. So we have to plug the stuff into the formula to get our answer back. So the A is what we're going to be looking for. Your P is the 10,000 that you're investing. Your R, remember, it's 8%, but when you write your R, it's 0.08. Your N is quarterly compounding, so quarterly means 4, and your time is 5 years. And so now you take all this information and you're simply just going to plug it in to your formula to get your answer. And so when you do this, so after 5 years, you should have roughly about $14,859.47. So that's what this is saying. Okay, so there's your formula. That's all the information plugged in. So this is the A value here. So that's what it's asking. The same question, except instead of being compounded quarterly, is compounded continuously. So the only thing that we need now is we still need our P, but we only need the R and a T. I don't need to worry about that. So we know our R is going to be the 0.08. We know the T is 5 and our P is going to be the 10,000. Plug it into the formula, your PERT formula, because it's compounded continuously, and you wind up with $14,918. Okay? So just remember, when you're putting all this together, pay attention to what they're asking of you. Pay attention to how you're compounding. Is it continuously, or is it going to be specific times a year? Make sure your time is always going to be in the terms of years. So they give you 18 months. That's 18 over 12. All right. That is it for 4.1 and your exponential functions. So make sure you get in there and get your homework done. I think there's only 13 questions for this one. It's a very short homework, which is really nice. So if you have any questions, make sure you're sending me an email, sending me a remind so I can answer your questions. And with that being said, if there's nothing else, I will talk to everybody soon. Have a great day, everybody. TTFN. Ta-ta for now.